Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. This is Cambridge IGCSE Chemistry 0620. So today we will be discussing one of the recent exam papers, which is May June 2025 paper 41. So let us get started. So question number one is a list of substances is shown. Okay, so we have different options over here. Answer the questions using the list of substances. Each substance may be used once, more than once, or not at all. State which of these substances is a basic oxide. Now, whenever you need to remember that which one is a basic oxide and which one is an acetic oxide. So one of the things that I teach my students is this, B-man. Okay. Now, from this, you can see that basic oxide is metal oxide. Then A stands for acidic oxide and N stands for non-metal oxide. Okay, this makes life a lot easier for students. So if the question is asking that what is a basic oxide, that means we must look for a metal oxide. So if we look over here, then we can see clearly that the second option is calcium oxide, and calcium is a metal. So this is going to be my answer to part A. All right. Part B says contains carbon atoms only. Now you need to look for substance that contains carbon atoms only. Now, if it contains only carbon atoms, the answer could be one of two. It could be either graphite or diamond because these are the only ones which are in your syllabus, right? The allotropes of carbon, as we say. So we can see from our options that we have graphite over here. Okay, so this would be graphite. Part C, which substance is manufactured by fermentation. Now, fermentation is a topic that comes in organic chemistry, so you must know that in this process, what we manufacture is ethanol from glucose. All right, so therefore, ethanol is over here. So that is going to be our answer. Part D, which substance is produced by the decomposition of vegetation? Now, decomposition of vegetation, this is a source of one of the atmospheric pollutants or air pollutants, which is methane. All right. So even I didn't have to look at the option because this is only this is the source only for methane gas. Okay. All right. Which substance contains aluminium oxide? All right. So if we look at our options, the first option is bauxite. So we know that bauxite is the ore of aluminium and it contains impure aluminium oxide. All right. So therefore, this will be bauxite. Part F, causes acid rain. Okay. Now there are only two gases which are responsible for causing acid rain. One of them is oxides of nitrogen, okay, and the other is sulfur dioxide, and the one which is in your options is sulfur dioxide. Then part G is which substance is a simple molecule with 11 atoms. If it says a simple molecule, that means it is talking about covalent substance, right? It is talking about a covalent compound. So let us see. Calcium oxide, this is an ionic compound. Ethanol, I need to write its formula first. So the formula for ethanol is CH3 CH2OH, right? So how many atoms do we have? Let's count. 1 plus 3, that's 4. 5 plus 2, 7. 8, 9. Okay, so ethanol is not the answer. Then let us look at methane. Methane is CH4. This contains only 5 atoms. Nitrogen, okay, that's N2, only 2 atoms. Oxygen is 2 atoms. Propane is C3H8, right? So therefore, we can see 3 plus 8, that is equal to 11. So therefore, propane is the answer. Now, if you don't remember the formula for propane, then you should at least remember that alkanes have the general formula CnH2n plus 2. So therefore, because propane is because for propane there are three carbon atoms, right? So therefore, this would be 2 times 3 plus 2, and hence you get C3H8. All right. Now, part H, which substance is produced when limestone thermally decomposes in the blast furnace. Okay, limestone is calcium carbonate. So when we heat calcium carbonate, thermally decompose means that you heat it and then it breaks down into different substances. So calcium carbonate when heated forms calcium oxide and carbon dioxide. So therefore, the answer is going to be calcium oxide. Now remember, at the beginning of the question, they told you that each option can be used once, more than once, or not at all. So calcium oxide comes twice in the answer, right? So therefore, that's not a problem because they've already told you that. All right. Part I, the reason why I'm highlighting this is because sometimes students this type of questions, they throw them off. They think that, okay, how can an option occurs twice in one particular question, right? So that's why you have to read every single statement, every single instruction on the question, so that you don't miss any part of it. Because a lot of the times what happens is they don't even read this part, they read the options and then they immediately come to part A just because they want to save time, which is okay as long as you don't miss out the instructions. Okay, do not miss out any statement. Remember, Cambridge does not give you any useless statements. Everything has a reason. Okay, so make sure that every part of the question is read without sorry, before you answer the question. Okay, all right. Part I is, which substance is a gas that is approximately 21% of clean dry air? So we know that this is going to be oxygen. Then which substance is a monomer in addition polymerization? Now, in addition polymerization, we know that this type of polymerization only occurs in alkenes. Okay, so our monomer is going to be an alkene. So I have to look for an alkene in our options. In the first row, there is no alkene. In the second row, we can see that there's propene over here. Okay, so therefore, my answer will be propene. All right, that is the end of question number one. Question number two is, atoms are made of electrons, neutrons, and protons. Complete table 2.1. So this is a question that comes sometimes in the papers, okay, but it is equally important to be studied because this is a whole table that has appeared multiple times in the previous exam papers, but not so frequently. All right, so here you have to mention that what are the relative charges of each of these subatomic particles. Okay, so a charge on an electron is going to be -1, and a charge on proton is going to be +1. Okay, make sure that you mention the charges. Don't just write 1 for proton. The relative mass of electron is 1 upon 1840, that is given to you. Neutron has a mass of 1 atomic mass unit. Okay, we call this AMU, but you don't have to write this. Okay, you just need to know this. And for proton as well, we have 1 atomic mass unit. Okay, so this is optional, but you can only write the numbers if you want to. Okay, part B. Atoms of the same element are known as isotopes. So you have two isotopes of potassium. Complete table 2.2 to show the number of electrons, neutrons, and protons in one atom or ion of these isotopes. Okay, so let's look at the first one. So here we know that when we have two numbers, okay, the lower number is the proton number. Okay, so this is going to be 19. The number of neutrons can be worked out by subtracting 19 from 39. So 39 minus 19 is going to be equal to 20. So this will be 20. All right. Now, as for electrons, because this is an atom, right, it does not have a charge over here. So we know that this is an atom. Within an atom, the number of electrons and number of protons are equal. So therefore, there will be 19 electrons. Because an atom is neutral, it does not have a charge, right? And this is the exact reason why it does not have a charge, because if you have 19 protons and 19 electrons, the charges cancel each other out. The next one is, now this is a positive ion. Okay. Now again, I'm going to write the number of protons first. So this will be 19. Then I can work out the number of neutrons. So 41 minus 19. Okay. So 41 minus 19 is going to be 22. As for electron, because it has one positive ion, that means that it has lost one electron to complete its outer shell. So the original number of electrons were 19. So after it has lost one electron, the remaining electrons would be 18. Okay. All right. So let's move to the next one. Part 2 is table 2.3 shows the relative masses and the percentage abundances of the two isotopes in a sample of potassium. Relative mass of isotopes, so you have 39 and 41, and the percentage abundance is 90% and 10%. Calculate the relative atomic mass of this sample to one decimal place. Now, the general formula that we use is average MR is equal to, so first of all, I'm going to take this value 39 and I'm going to multiply this with its given percentage abundance. Okay, so because if let's say that I have 100 atoms, out of which 90% are going to be of this isotope and 10% are going to be of this isotope. So basically when we are multiplying by 90, we are actually saying that this is how much uh, this type of isotope is contributing. Okay, so 39 times 90 plus the next one is going to be 41 multiplied by 10. And now because the total percentage is out of 100, right? So you are going to divide this by 100. All right. So 39 times 90 plus 41 times 10. So this is going to be equal to 3920 divided by 100. Okay, cancel the zero. And now you can shift one decimal place to the left. So the answer will be 39.2. All right. So do not round this off because they are asking you to give it to one decimal place. So my final answer is going to be 39.2. All right. This is the average relative atomic mass for potassium. Sorry, this should be AR, not MR. MR is for molecules, right? Okay. The third part is an isotope of aluminium has a nucleon number of 27. Aluminium has a relative atomic mass of 27. State what conclusion can be made from this information. Okay. All right. Okay, so let's think about it in this way. We just did a question about potassium, right? So let me write this down quickly. We saw that there were two isotopes of potassium, right? And over here we have only one isotope of aluminium. So this is 27 and this should be 13. Okay. Now, for this one, you can see that there were two different isotopes. And when I try to work out the average relative atomic mass in the previous part, so it turned out to be 39.2, right? Because it was the average of these two values, right? But for aluminium, it says that its relative atomic mass is also 27, exactly 27 as compared to this one. So what conclusion can we draw from this? The conclusion that we can draw from this is that aluminium has only one isotope, because if it would have had another isotope, the number might be a bit the number would have been a bit different. It might have been 27.1, 27.2, or 3 or anything else, but it could not have been exactly 27. So because it has exactly 27 AR value, okay, that tells you that it only has one isotope. Okay, so we can say that aluminium has only one isotope with a relative atomic mass and nucleon number of 27. So basically, we're saying that it has only one isotope that has the relative atomic mass as 27, and it also has nucleon number of 27. Okay, part C is a calcium atom has the electronic configuration of 2882. Give the formula of one atom and one negative ion. Okay, one atom and one negative ion that has the same electronic configuration as Ca2 positive. Okay, so first of all, let us work out that what would be the electronic configuration of Ca2 positive. Okay, the original atom has 2882. Now, if calcium has to form an ion, that means it has to lose its outer shell electrons. So there are two outer shell electrons, so it has to lose both of them. So therefore, my new electronic configuration will be 288. Okay, so this would be equal to 18 electrons. All right, now we need to give an atom, give the formula of one atom. Okay, so you have to give formula, no need to give the name or anything else, but the formula of one atom that has the same electronic configuration. So an atom could be the element from the periodic table. Okay, so we have to look at the periodic table, that which element has 18 electrons and 18 protons, because if it is an atom, it has to have the same number of protons and electrons, right? All right, so let us okay, let me open it over here. Okay, so let's see, the top values are the proton numbers. So if you look over here, this one, 18, so this is argon. All right, so argon is a group 8 element, and therefore we can say the formula is going to be Ar. Okay, all right, now we need a negative ion. So a negative ion would be something that has gained an electron. Okay, and then it made 18 electrons. So originally it might have had less electrons. Okay, so if let's say that the atom of okay, so whatever atom is going to come over here, right, initially it must have had less electrons. After gaining extra electrons, then it got 18 electrons. So let's look at the possibilities over here. In order to get the electronic configuration of argon, we can have phosphorus, we can have sulfur, we can also have chlorine. Okay, there could be three options, right? So let me show it to you how this works. If we have phosphorus, so there are 15 electrons. Okay, that means that in the outer shell of phosphorus there are 5 electrons, and it needs a further 3 electrons to complete its outer shell. So if it can gain 3 electrons, then it can achieve the electronic configuration of argon. Right? So for this particular one, my answer could be P3 negative. Okay, that's one possible answer. Second possible answer could be, what was the next one? Sulfur. Now sulfur has 16 electrons, so that means it has 6 electrons in its outer shell. It needs just 2 more electrons. So if it can get 2 more electrons, now it has achieved 18 electron configuration. So therefore this one would be S2 negative. The last possibility could be chlorine. Chlorine has 17 electrons. So if I draw the structure, so it has 7 electrons in its outer shell. It just needs 1 electron so that it can get the electronic configuration of 18. So that means this one would be Cl negative. Because chlorine has gained one electron, it will get one negative charge. Sulfur gained two electrons, it is going to get two negative charge. Phosphorus gained three electrons, so it is going to get three negative charge. So any one of this could be a possible answer. All right. So that is the end of question number 2. Let us move to question number 3 now. This question is about copper and compounds of copper. Describe the bonding in a metallic element such as copper. Now, the question is about bonding. Okay, there are three types of bonding in your syllabus that you have to know. One of them is ionic bonding, which is between a metal and a non-metal. Then covalent bonding, that is between two non-metal atoms. And the third is metallic bonding, which is specific to just metals. Okay, now, so here we have to describe, and it is a 3-mark question. So your description should be very clear. There are some keywords which must be part of your answer. Okay, so you have to look carefully that what information do I have to include in my description. Because look, let me be honest here. Sometimes the papers are not too difficult. Okay, but they become difficult because students are not aware of the correct definitions. They're not aware of the correct keywords that must be part of the description. Because look, it says describe, so that means they require you to explain in great detail. But even when you're explaining in great detail, if you miss out the keywords, then there's a chance that you're going to miss the marks. Okay, all right. So first of all, I'm going to say that in metallic bonding there is strong, or there are strong electrostatic forces of attraction between positive copper ions and C of delocalized electrons. Okay. Now, in this one definition or in this one description, let us read that what part of the what part of the definition I have covered over here. First of all, I mentioned that the type of forces which are present are strong electrostatic forces of attraction. Now, what do we mean by all this huge word, electrostatic forces of attraction? It just means that there is an attraction between something which is positively charged and something which is negatively charged. You might have studied about static electricity if you have studied physics, right? So that is between a positive and negative. So over here, what is positive? It is the metal ion. Now, because the question was specifically about copper, that is why I wrote copper ions. If it generally asks you that, okay, describe the bonding in a metal, then I would say between positive metal ions. Okay. And then you have C of delocalized electrons. What is delocalized electrons? These are the electrons that the metal atoms have lost. So now these electrons are traveling throughout the metallic structure. Okay. All right. So now all of this, okay, this occurs that there are strong electrostatic forces of attraction between positive copper ions and C of delocalized electrons in a giant metallic lattice. Okay, lattice basically means a regular arrangement. Okay, so this type of arrangement is actually regular, it has a repeated pattern. Okay, now why am I writing so many things? Because I don't exactly know that how marking scheme is set. Because sometimes what happens, let me tell you something. Sometimes you'll have 1 mark for this, then another mark for this, the third mark is going to be for this. Okay, and there's going to be another mark for this, but this is not 4-mark question. So sometimes what they're going to do is they might combine the positive copper ions and C of delocalized electron. They'll count this as 1 mark. Second mark will be strong electrostatic forces, and the third mark is going to be giant metallic lattice. Because you don't know your marking scheme, right? So therefore It is better to be on safe side. So this is going to be a complete answer. If you can write this answer, then there's a chance that, not a chance, then I'm sure that you won't lose a mark. Okay. All right. The next part is explain how solid copper conducts electricity. Now, how do metals conduct electricity? These delocalized electrons, which are traveling throughout the structure, right? These are responsible for conducting electricity. Okay, because they can move, they can flow, right? So this is what causes the electricity to flow through the metal. So we say that the delocalized electrons move throughout the structure. All right. Okay, part B. Copper is in alloys such as brass. State one reason why alloys are more useful than pure metals. Okay, now why alloys are useful than pure metals? Now, then you have to look for a weakness, right? That, okay, what is a weakness that I could have in a pure metal? An alloy is a much better option. Okay, so one of them is strength, because in alloys you mix different metals, so you strengthen it by using different metals. Okay, so we can say that alloys are stronger. Okay, or you can also say that they're harder. So this is the physical property that is useful in alloys. Name the substance that is present in brass other than copper. So brass is made of only two metals. One of them is copper and the other is zinc. Part C. Copper 2 sulfate crystals are made by the reaction between copper 2 carbonate and dilute sulfuric acid. Okay, so we have copper 2 sulfate is the product, and this is your base and this is your acid. Okay, the sulfuric acid has a concentration of 0.1 mole per cubic decimeter. Powdered copper 2 carbonate is added to dilute sulfuric acid. The mixture is stirred. A reaction occurs. More copper 2 carbonate is added with stirring until the reaction stops. Unreacted copper 2 carbonate is separated from aqueous copper 2 sulfate by filtration. Then in step 4, aqueous copper 2 sulfate is heated until some of the water evaporates. Step 5. The remaining solution is allowed to cool and crystallize. Step 6. The crystals are removed and dried. Now, this is six-step process is basically describing the neutralization process. Okay. Now, it says give two observations in step 1. So let's read step one more time. Powdered copper 2 carbonate is added to dilute sulfuric acid. The mixture is stirred. A reaction occurs. Now, because this is a carbonate, and when you add a metal carbonate to acid, the very first thing that you see is fizzing. Okay, because carbon dioxide is released, and that is what causes fizzing. So we can say fizzing, or you can say effervescence. Okay, or you can also say bubbles of, okay, do not say bubbles of carbon dioxide gas, because when we are saying observation, then they only want you to tell what you can physically see. I cannot physically see that this is carbon dioxide. That is by theory, right? What I can see is bubbles of colorless gas. Okay, so make sure that you understand very carefully that whenever the question asks you to give observations, then always mention those aspects which you can see with your own eyes. Okay. All right, so the next one would be, because when we add copper to carbonate, it is going to immediately start reacting, right? So it's going to dissolve into the acid. So you won't be able to see uh, the you won't be able to see the solid, right? So we can say that the solid or copper to carbonate dissolves, okay, or it disappears. Okay, that's the first thing. So we can say solid dissolves, or you can say disappears. Okay. Now, usually in a neutralization reaction, if your base is a carbonate, then these two observations are fixed. Okay, if your base is a carbonate and you're adding it into an acid, then definitely you're going to see these two observations. But specifically to this particular scenario, because we have copper 2 sulfate being formed, okay, so the color of copper 2 sulfate is a blue colored solution. So therefore, we'll also see blue solution forms. All right. So that could be another one of the observation, but you only have to give two of them. Then it says state why the reaction stops in step 2. Now it says more copper to carbonate is added with the stirring. Now we are continuously adding more copper to carbonate, but a point comes where the acid is finished, right? The acid particles have all reacted, so now there's no more acid particle left to react. Simple as that. So that is why the reaction stops. So we can say that all the dilute sulfuric acid has reacted, or you can say used up. Then we can then the question is name the residue in step 3. Okay, what was step 3? Unreacted copper to carbonate is separated from aqueous copper to sulfate by filtration. So if you read carefully, they've already told you the answer. Unreacted copper to carbonate is separated. Okay, when you have filtration process, okay, so that something that's left over here, right, on your filter paper, that is what we call residue. So obviously that is going to be something which is unreacted and which was undissolved, right? So that would be this one, copper to carbonate. So the copper to carbonate which did not react, which did not dissolve, once we separate it, once we filter it, then it is going to be separated as a residue. So this would be copper to carbonate. Okay, number 4, name a substance other than copper to carbonate that can be added to dilute sulfuric acid to produce aqueous copper to sulfate. Okay, now if I want to make copper to sulfate, so there are three ways that I can do it. I can add a metal carbonate, I can add a metal oxide. Okay, sorry, let me repeat it, but in a general term. Okay, if I want to make a metal salt, okay, so I can take an acid, and within my acid I can put four of the things, right? I can put a metal, I can put a metal oxide, I can put a metal hydroxide, or I can put a metal carbonate. Okay, now metal carbonate is already done. In this case, metal, that means copper, because copper is less reactive, it cannot react with the acid. Okay, so therefore this one is out. The only two options left are metal oxide and metal hydroxide. So I can say that the other alternative could be copper to oxide, or the second one could be copper to hydroxide. Both of them are correct answers. But remember, you must give only one because they've asked you to give one, so just give one. Number 5, the solution at the end of step 4 contains the maximum amount of copper 2 sulfate that will dissolve at that temperature. State the term used to describe this type of solution. Okay, this is actually a definition of one of the terms that is closely associated with neutralization reaction. Okay, and that definition is for saturated solution. So in a saturated solution, your solute has been dissolved to a maximum quantity at that particular temperature. So that means that at this particular temperature, you can no longer dissolve any more of the solute. All right. Okay. Step 1 is repeated using sulfuric acid of concentration 0.2 mole per cubic decimeter instead of this. So this was the original and this is the new, right? All other conditions are the same. So basically what we have done is we have increased the concentration. It says the rate of reaction increases. Explain why the rate of reaction increases. Give your answer in terms of particles. Okay. So we say that as the concentration increases, as the concentration increases, there are more particles per unit volume. Okay. And okay, let me explain this part first. So if now, let's say that this was the initial case, okay, and over here, these were my acid particles. That's it. This is one volume. But now that I have increased my concentration, so that basically means that within this one volume, now I have double the particles, right? So we still have one volume, but now we have more particles per unit volume. Okay, so if there are more particles of the acid right now, because I have added a higher concentration of that, so that basically tells you that there will be more collisions per unit time. Okay, so that's why the rate of reaction is going to increase. So there are more particles per unit volume and more collisions per unit time. Make sure that you mention this in terms of time. Okay, time is important factor. That if let's say that there were 20 collisions taking place per second previously, now there might be 45 collisions or 40 collisions taking place per second. Okay, so when you say per unit time, that gives you an accurate comparison between the two situations. Okay, and then lastly you can say hence the rate increases. All right, next part is copper 2 sulfate crystals have the formula CuSO4.5H2O. State the term used to describe a substance that is chemically combined with water. Now, basically, this is copper 2 sulfate crystals, right? So the crystals are basically called hydrated copper 2 sulfate. Okay, so this is the term that we use for crystals. All right. Okay, question number 4. This question is about nitrogen and its compounds. Nitrogen contains molecules with the formula N2. Complete the dot and cross diagram in figure 4.1 to show the electronic configuration in a nitrogen molecule. Show the outer shell electrons only. Now, this is something that you must know from your uh, study. Okay, when you might have studied about this chapter about covalent compounds, that the bond between nitrogen is actually a triple bond. Okay, so just like for example, if I have hydrogen, so hydrogen is H2, right? So there's a single bond between the hydrogen atoms. Then we have oxygen. Oxygen is O2. There's a double bond between the two oxygen atoms. Similarly, nitrogen has a triple bond between its atoms. Okay. Now, each single bond tells you that there has been a share of electron. So there has been a share of one pair of electron. So that basically means that if I were to talk about hydrogen, so that means one electron goes from here, one electron goes from here. So there's a pair of electron being shared. In case of oxygen, there are two pairs of electrons being shared. Each oxygen atom is going to share two of its electrons. So in this case, there are going to be three electrons from each of the nitrogen. So let's say from the left hand side, I'm going to represent this by cross. Now, right hand side, this one shares its electron. That's one pair. Now, the left hand side, you have another cross, and from right hand side, you have another dot. Then from left hand side, another cross, and then from right hand side, another dot. So now you can see that there are three pairs of electrons, which is a total of six electrons. Okay. Now, nitrogen is in group 5. So that means that its outer shell has 5 electrons. So originally, each one of the nitrogen atoms had 5 electrons. They have shared only 3. So that means within their own shell, the own part of their shell, they must still have two more electrons. Okay, so this one has one and two, and this one has one and two. Now let's count it. If I were to only focus on the left nitrogen, let's hide this one. Okay, how many electrons can you see? One, two, three, four, five, six, seven, eight. So this is perfectly fine because you cannot have more than eight electrons. Similarly, if I move this to the right hand side, now if we count this one, these are six electrons, and then you have seven and eight. So even this nitrogen now has eight electrons. Okay. All right. Part B. Ammonia is manufactured by reacting nitrogen with hydrogen in the Haber process. State three typical conditions for the reaction between nitrogen and hydrogen in the Haber process. So you have three conditions. Okay. The first one is temperature is 450 degrees Celsius. Okay. The next one is pressure. That is, now pressure you can write in two ways. Okay, if you want to write in atmospheric pressure, that would be 200 atm, but if you want to write in kilopascals, then you can say 20,000 kilopascals. Okay, so 1 atm is equal to 100 kilopascals. So from that conversion, if you want, you can write in this way, but other than that, you can simply write 200 atmosphere atm. Okay, then the last one is iron is used as a catalyst. So these are three conditions. Write this symbol equation for the chemical reaction in the Haber process. Now, Haber process is a reversible reaction. So therefore, make sure that you don't forget this. Nitrogen plus hydrogen. This is a reversible reaction. And then you have ammonia. Now we have to balance it. Let me just drink some water. All right. So here we can see that we have two nitrogen on right hand side, and on left we have now two nitrogen, so that is balanced. Hydrogen is 6 on the right hand side, so in order to balance it, I'm going to write 3 over here. Okay, make sure that you remember this. You cannot write a chemical equation which is unbalanced. Okay, always write balanced chemical equation. This 1 mark actually means that you must give, first of all, your reactants and products should be should be correct, and then the balancing should also be correct. Ammonia is converted into nitric acid in a two-step process. In step 1, ammonia and oxygen are passed over a catalyst. Balance the symbol equation for this reaction. Okay, so let's see. We have 4 nitrogen on left hand side. Okay, let me write this down. Nitrogen is 4, hydrogen, okay, let me reduce the thickness of the pen so we can fit all three elements. So this is nitrogen, this is hydrogen, and this is oxygen. Let me zoom it in. Okay, now we have 4 nitrogen, we have 3 hydrogen, and we have 2 oxygen. Sorry, my bad. 4 times 3, that would be 12 hydrogen. On the right hand side, we have 1 nitrogen, then for hydrogen that is 2, and for oxygen that is 1 and 1, 2. Okay, now first of all, we are going to balance everything other than oxygen and hydrogen, okay, because these are the ones that change again and again, right? So we are going to balance everything other than that. So first I'm going to balance nitrogen. In order to balance nitrogen, I have to put 4 over here, so this becomes 4, but because of this, oxygen also changes. So now we have 4 plus 1, 5 oxygen atoms. Okay, now to balance hydrogen, I can see that there are 12 hydrogen on the left hand side, and on the right hand side I only have 2. So in order to change this, I'm going to write 6. 6 times 2, now that is 12. But because of this, oxygen also changed. Now do not just add 6 to this one. Okay, that can work in some cases, but in some cases that cannot. So count again from the beginning. So now we have 4 oxygen over here and 6 oxygen over here. That makes it 10 oxygen. Okay, if let's say that you would have added 6 just to 5, that would have become 11, isn't it? So you see, that was an arithmetic error. So whenever you change something, count from beginning. Now in order to balance oxygen, I only have to add 5 over here, because if I add 5, 5 times 2, that becomes 10. So nitrogen is balanced, hydrogen is balanced, and oxygen is also balanced. So therefore, this is going to be my balanced chemical equation. Then it says give the oxidation number of nitrogen in NH3. Okay, now this is something that was added in your syllabus in 2023. Okay, this was updated in 2023, so you won't find questions related to this type of question before that. Okay, now how do we do this? First of all, I'm going to say that the charge on N plus charge on H is equal to charge on NH3. Okay, first and foremost, what is the charge on NH3? Because this is a molecule and you can see clearly that there is no charge over here, so this is 0. Okay, now let's talk about N. How many atoms of N can we see in NH3? It's only one, so that would be 1 multiplied by the charge on N, which is what we need to find, right? The charge or the oxidation number is the same thing. Okay, plus the charge on hydrogen. So first of all, how many atoms can we see? We can see that there are 3 atoms. What is the charge on hydrogen, or what is the oxidation number? It is positive 1. Okay, now simplify this. You get x plus 3 equals to 0. You shift 3 to the other side, x is equal to minus 3. So the charge on nitrogen in this case is minus 3. All right, okay. For the next one, let me do the same thing. Let's just change this. So nitrogen is the same, but now we have oxygen. Okay, so the charge on nitrogen, the charge on oxygen, and the charge on NO. Again, NO, nitrogen monoxide, is a molecule. You can clearly see there is no charge over here, right? Okay, what do I mean by no charge over here? If let's say the question was about this NH4 positive, and you had to find the oxidation number of nitrogen in this case. So in this case, I can see that the charge, overall charge, is plus 1, right? So I would have written plus 1 on my right hand side over here, right? So this is what what I mean when I say that you can see that on top of this I see there is no charge. So therefore this is going to be 11. Sorry, where does it where did 11 come from? This is 0. Okay, all right, for nitrogen, there is one atom and the charge is going to be X because that is what we need to find. Oxygen is one atom and its charge is minus 2. We know that oxygen is from group 6. So elements of group 6, elements that belong to group 6 have a charge of minus 2. Again, simplify this. So X minus 2 equals to 0. Therefore, X is equal to positive 2. So here the charge is going to be positive 2. All right. Number 3, define oxidation in terms of oxidation number. Oxidation basically has 3 types of definition. Oxidation is loss of electrons, that you remember by oil rig. Second is gain of oxygen, is also called oxidation. The third one is increase in oxidation number, is called oxidation. Okay, so I'm going to say oxidation is the increase in oxidation number. Part 4. In step 2, oxygen and water react with NO to produce nitric acid as the only product. Okay, write a simple equation for this reaction. Okay, so they have given you the reactants. So oxygen plus water plus NO, and it says that nitric acid is the only product. So the formula of nitric acid is HNO3. Okay, now we have to balance it. So we have one nitrogen on left, one nitrogen on the right. Then we have two hydrogen on the left, and we have only one hydrogen on the right. So I'm going to add two over here. Now, because of this hydrogen, okay, because of this two, hydrogen becomes two, but nitrogen also becomes two, right? So now I have to add two over here. Okay, so let's see. Now, how many oxygen are there? We have two oxygen from here, then plus one, that is three, plus two, that is five. Okay, but on the right hand side, we have six. Okay, now when you have this type of situation where okay, when you have this type of situation where everything is balanced except for a diatomic molecule, so the diatomic molecule is oxygen, right? Everything is balanced other than oxygen. So what do we do is we multiply everything by 2, except for this one, because this one we will balance at the end. So this becomes 2, this becomes 4, and this also becomes 4. Okay, now let us count again. Hydrogen are 4 on the left hand side, hydrogen are 4 on the right hand side. Okay, that's balanced. Nitrogen is 4 on the left hand side, nitrogen is 4 on the right hand side, that is also balanced. Oxygen is 12 on the right hand side. Here we have 4, here we have 2, so that is 6. That means I need to have 6 on this side, so I can add 3 now. Okay, so that is how you balance it. So the last step, let me repeat it one more time. Whenever you are stuck in a situation where everything else is balanced except for an element which is diatomic by nature. Okay, diatomic are oxygen, nitrogen, hydrogen, and all group 7 elements. Then what we do is we multiply the whole equation by 2 except for this diatomic molecule. Okay, because after we have multiplied everything by 2, then we analyze that, okay, what do I need to put so that I can now balance this one, just like I analyzed, and then I put 3 over here from my side, right? Okay, the next one is ammonia is converted into ammonium sulfate. So we have 360 cubic decimeter of ammonia gas measured at RTP that reacts with sulfuric acid. Calculate the mass of ammonium sulfate produced using the following steps. Okay, so calculate the number of moles of ammonia in 360 cubic decimeter. So for this, we know there's a formula. Volume of gas is equal to 24 cubic decimeter multiplied by N. So we actually remember this by this shortcut. V equals to 24N, right? Now, this formula is only applicable when your volume is in cubic decimeter. So because it is in cubic decimeter, now I can say that 360 is equal to 24 times N. Therefore, N is equal to 360 divided by 24. Okay, let me grab my calculator. So 360 divided by 24, that gives us 15 moles. Okay, now don't get confused that, okay, how can you have such a big number of moles, because look at the amount of gas. 360 cubic decimeter is a huge number. Okay, because this is not even cubic centimeter. Cubic decimeter is a lot bigger unit than cubic centimeter. Okay, so you can have situations where you can have higher number of moles. Then calculate the number of moles of ammonium sulfate. Now, if the question has asked you to calculate moles in the first part or in the previous part, and then immediately after that, it again asks you to calculate the number of moles, but of something else. Over here, it was ammonia. Over here, it is ammonium sulfate. Here we use a concept called mole ratio. Okay. What we do here is, over here, it was ammonia. So I'm going to write ammonia over here. Here I have ammonium sulfate, so I'm going to write ammonium sulfate. From the given equation, I'm going to see that what is the mole ratio. Okay, so from here I can see this is 2 and over here there's 1. Okay, so this is 2 ratio 1, and from my calculation I found out that ammonia has 15 moles. So if it has 15 moles, how much ammonium sulfate would be produced? Okay, now we just cross multiply over here. So we have 2x equals to 15 times 1. So x is equal to 15 upon 2, which is 7.5 moles. Next one is calculate the mass of ammonium sulfate produced. The MR of ammonium sulfate is given to you. For the mass, there's only one formula. First of all, the basic formula is number of moles equals mass upon MR. I'm going to rearrange this formula. So we have mass equals number of moles multiplied by MR value. Number of moles of ammonium sulfate is 7.5, which we worked in the previous part, multiplied by the MR value, which is 132. Okay, so multiply it and you can get your answer. So 7.5 times 132, that is equal to 990 grams. All right, so that is the end of question number 4. Okay, question number 5. Methanol is manufactured by the reaction between hydrogen and carbon monoxide. An equilibrium mixture is produced. State what happens to the concentration of methanol when the reaction is at equilibrium. Explain your answer in terms of rate of forward and reverse reactions. Okay, so first of all, it says that when the reaction is at equilibrium, what happens to the concentration of methanol? Okay, now this is actually asking you the definition of equilibrium, but they've only twisted the words a little bit. Okay, because obviously in every exam paper they have to find a new way of asking you the question, right? So here you have to mention that, okay, what happens during equilibrium, and it is 2 marks, right? So if you're well versed in this in the definition, then you can easily recognize this, that it is only asking you the definition. So we say now, at equilibrium, there are two things that take place. The first is the rate of forward reaction is equal to the rate of reverse reaction. Okay. And secondly, the concentration of reactants and products are no longer changing. Okay. So that is the general definition. But we have to see that what exactly is it asking. It says state what happens to the concentration of methanol. Okay. So only we're going to explain this. Okay. So we'll say that at equilibrium, the concentration of CH3OH no longer changes. Okay, that's the first point. The second point is now it says explain your answer in terms of rate of forward and reverse reactions. So now we will say that and the rate of forward and reverse reactions are equal. Okay, now this word is very important. If you forget this word or you miss this word out, okay, you're going to lose this mark, because the rate of forward and reverse reaction is not the same thing as that the forward and reverse reaction are equal, because they're not. The forward reaction is in this direction, reverse reaction is in this direction. So they're not the same. But how quickly they take place, the rate at which these two reactions take place, that is the same. Okay, so that's that this one word makes a very big difference. Okay, part B is the reaction is carried out at a pressure of 75 atmospheres and a temperature of 250 degrees Celsius. State two disadvantages of using a pressure below 75 atmospheres. That means that if you reduce the pressure, okay, what are the two disadvantages? Now, one of the advantage or disadvantage, okay, we can say one of the things that will be affected is the rate of reaction, okay, and the second thing that will be affected is the yield. Yield means the amount of product. So if we look from this perspective, then what happens to the rate of reaction if I decrease the pressure? So we know that if the pressure is decreased, okay, there will be less particles per unit volume and there will be less collisions per unit time. Okay, so therefore we can say rate of reaction decreases. That is the first disadvantage. Okay, the second disadvantage is that if we use a lower pressure, okay, so when we use a low pressure, the position of equilibrium moves to the side that has higher number of gas moles. So let us count how many gas moles do we have on both sides. So on the left hand side we have 2 plus 1, that is 3 gas moles, and on the right hand side it's only 1. Okay, so if I decrease the pressure, position of equilibrium moves to the side that has high number of gas moles. That means it will shift to the left hand side. If the position of equilibrium moves to the left side, basically it means that now more of the reverse reaction is going to take place. If more of the reverse reaction is going to take place, your yield or the amount of product is going to decrease. The whole purpose of this reaction is that I want to manufacture methanol. Okay, so if my yield is decreasing, then that is a disadvantage, right? So we can say the yield of methanol, or if you want, you can write the formula too, decreases. Okay. Part 2 is complete table 5.1 using only the words increases, decreases, or no change. So if a catalyst is added, what is the effect on the concentration of CH3OH, that is methanol, at equilibrium? Okay, so basically it is asking that if I add catalyst, what is the effect on yield? And if I add catalyst, what is the effect on rate? From your theory or from your lectures, from your study, you must know that catalyst has no impact on the yield, zero impact. Okay, because catalyst can only increase the rate of reaction, it cannot affect how much more can I increase my product. Okay, that is not the department of catalyst. That can happen only by pressure, temperature, or by concentration. Okay, so that's why I'm going to write no change over here. And definitely we know that if I add a catalyst, my rate of reaction increases. Next one is, if a temperature of more than 250 degrees Celsius is used, the yield of methanol decreases. Okay, if a temperature of more than 250, that means if we use a higher temperature, what happens? The yield decreases. Okay, state what can be deduced about the forward reaction. Now, just like I mentioned about pressure, okay, there is also a criteria for temperature, that high temperature favors the endothermic side. Okay, high temperature favors endothermic side. If you use a high temperature and the yield is decreasing, that means the position of equilibrium must have shifted to the left hand side, right? Because methanol is over here, this is my methanol. Okay, so if by using a high temperature methanol is decreasing, right, that means that left, the position of equilibrium must have shifted to the left, so the reverse reaction is taking place. That means that this is the endothermic side. If the reverse is the endothermic side, then automatically your forward reaction is going to be exothermic, because in a reversible reaction, if one direction is endothermic, automatically the other is exothermic. So we can say that the forward reaction is exothermic. Forward reaction is exothermic. Suggest which of the elements from the list is a suitable catalyst for the reaction. Give a reason for your answer. So we have barium, carbon, copper, potassium, sulfur. Now from all of these options, we know that only a transition metal can act as a catalyst, right? So there's only one transition metal, which is copper. And the reason is going to be it is a transition element. Only transition elements can act as catalyst, or their compounds can act as catalyst. So like for example, during the Haber process, we know that iron is a catalyst used, and during the contact process, we know that vanadium 5 oxide is a catalyst used. So vanadium is also a transition metal, but over here its compound is being used uh, as a catalyst. Okay. Methanol is a member of the homologous series of alcohols. State two characteristics of all the members of a homologous series. So we know that we can say that they have the same general formula, they have the same functional group. Okay, there are three more that you can write. Okay, so we can also say that they have similar chemical properties. We can also say that two consecutive alcohols will differ by CH2 group, and we can also say that the members of the same group show trends in physical properties like boiling point. But to be very honest, the first three that I mentioned, which is that having the same general formula, same functional group, similar chemical properties, these are the most relevant and the top three answers. Okay, so these ones have the highest priority. The rest ones you should know, but do not use them as your first answers. That's my recommendation. Okay. The next one is state the molecular formula of an alcohol that contains five carbon atoms. So if you have five carbon atoms, then your prefix of that compound is pent. Okay, and because this is an alcohol, so its ending is going to be ol, right? So therefore the name is going to be pentanol. Sorry, my bad. It says the molecular formula. Okay, I didn't read that. Okay, it says the molecular formula, not the name of the alcohol. So okay, first of all we need to know that what is the general formula for this. Okay, so the general formula for alcohol is CnH2n plus 1, and then at the end you put OH. Okay, so that would be C5H 2 times 5 plus 1, and then you have OH. So that would be C5, 2 times 5 is 10, then we have 11 OH. Okay, but this is not the molecular formula. In molecular formula, you have only one element, then its number of atoms, another element, its number of atoms. So my final answer in this blank is going to be C5H12O. All right, this is going to be my final answer. So this working you can do with pencil elsewhere, or you can erase it later on, but the final answer on the blank is going to be this. You also have a blank page, so you can do rough working over there as well. Part D is carboxylic acids react with alcohols to form esters. Draw the displayed formula of an ester which contains three carbon atoms. So it says draw the displayed formula of an ester which contains three carbon atoms. So there are two possible answers that we can give over here. We can either draw methyl ethanoate, okay, or we can also draw ethyl methanoate, because in both of these cases you can have three carbon atoms. Okay, so I'll start with this one. So methyl ethanoate means, now in the ester, the name of the ester, the first uh, the first thing in the name of the ester, that is alcohol. Okay, and the last one is acid. So methyl, this tells you the alcohol being used, right? So this tells you that the alcohol used is methanol, and ethanoate tells you that the acid is ethanoic acid. But when we draw the structure, okay, the acid comes first, alcohol comes second. Okay, so I'm going to start with ethanoic acid. You have CH3, then we have carbon to oxygen double bond. Now for ethanoic acid, you would have had this one, right? But while you're making an ester, this OH is removed. Okay, all right. As for methanol, now the oxygen of methanol is connected with this ester, and then you have this structure. So let's say methanol is this, right? CH3, and then after that you have O and H. So the hydrogen of alcohol and the OH of the acid, okay, they are both removed. They combine to give you water as the second product, and this part of the chain, this part of the chain is connected to this part of the acids chain. So now you have an ester link. Okay, this is what we call ester link. So you don't have to show all of this, right? This is just for explanation. So all you have to show is this structure which is in the red. Okay, this is first possible answer. The second possible answer could be that if I'm using methanoic acid for this part and I'm using ethanol as my alcohol, so in that case my structure should look like this. This is the acid part of the ester. Combine this with the alcohol part of the ester. So this would be the structure of ethanol, except that it has lost its hydrogen and the methanoic acid has lost its OH. Okay, so this is the one possible answer, and this is the second possible answer. So I hope that this is clear. Butyl ethanoate is an ester. Name the alcohol and the carboxylic acid that react to produce butyl ethanoate. So as I mentioned, that the first part of the name that tells you the alcohol. So butyl tells you that this is butanol. The second part tells you the acid. So this is ethanoic acid. Okay. An organic compound has the following composition by mass. So this is carbon, this is hydrogen, and this is oxygen. Calculate the empirical formula of the compound. Okay. Now to work out the empirical formula, so what we can do is we can draw a table. Okay. So this is hydrogen and this is oxygen. Over here, first of all, we can write the mass, which is in grams. So these percentage, because this is percentage by mass, right? So I can say that this is 64.87, 13.51 grams. No need to write grams because I've already labeled over here, and 21.62. Step 2, calculate the moles. So we know that the formula for finding the moles is mass upon AR. So this would be 64.87 divided by 12. 12 is the AR value of carbon. Okay. For hydrogen, it is 13.51 divided by 1. And for oxygen, it is 21.62 divided by 16. Okay. So let me grab my calculator. 64.87 divided by 12 gives us 5 point, let me write this over here, 5.40583. This will be 13.51, and 21.62 divided by 16 gives us 1.35125. Now the next one is going to be mole ratio. In mole ratio, we divide all three of these by the lowest number of moles. Okay, so the lowest number of moles is this value. So 5.40583 divided by 1.35125. 1.35125, 13.51 divided by 1.35125, and 1.35125 divided by 1.35125. So you divide all the moles by the lowest number of moles. So this turns out to be 1. Okay, as for the first one, 5.40583 divided by 1.35125. So this gives me 4. Okay, and the second one is 13.51 divided by 1.35125. So this gives me 9.999, so that is 10. Therefore, my empirical formula will be C4H10O. Okay, so that's how you find the empirical formula. Okay, all right. Just one more thing over here. I just realized this one, because butanol has two esters, sorry, has two isomers. Okay, we have butan 1-ol and we have butan 2-ol. Okay, because this is butyl ethanoate. Okay, so this one is going to be butan 1-ol. Okay, because your ester is going to be it is going to be from the first carbon, right? So therefore that is going to be the isomer that we use. All right. Okay, question number 6. This question is about the periodic table. State the name given to group 7 elements. So that will be halogens. Then the next one is state which group 7 which group 7 element is most reactive. So we know that the reactivity, if you go down the group, the reactivity decreases. So therefore fluorine, which is at the top of the group, is the most reactive. Give the physical state and color of iodine at room temperature. The state is that it is solid. The color is that it is gray black. Okay, you have to be very specific, okay, in remembering these colors. When bromine is added to aqueous potassium iodide, a displacement reaction occurs. The equation for the reaction is shown. Write an ionic equation for the reaction. So now the ionic equation always takes place when you have these aqueous ions. Okay, bromine is going to be liquid, and iodine, because it says iodine solution will be produced over here, so that is also going to be liquid. Okay, so basically what happens is that potassium ion is same on both sides, so that will be cancelled out. So here we have Br2 plus 2I negative gives us 2Br negative plus I2. Okay, the next one is iodine and bromine react at high temperatures to form iodine iodine monobromide, IBR. The equation is shown. The structures of the molecules involved are I to I, so that is iodine to iodine, then bromine to bromine bond, and iodine to bromine. So you have all these bond energy values. Calculate the enthalpy change delta H for the reaction using bond energies in the table. Use the following steps. Calculate the total amount of energy required to break the bonds in 1 mole of iodine and 1 mole of bromine. So if I look at the equation, so this is 1 mole and this is 1 mole. All right. Okay. Now, the total amount of energy needed to break the bonds. Bond breaking always takes place in on the reactant side. Okay. So I'm going to write this over here, bond breaking, which is BB. On the reactant side, how many types of bonds do we have? We have iodine to iodine bond, and we have bromine to bromine bond. Okay, and how many of these type of bonds do we have? it's only one, right? So 1 multiplied by the bond energy value, which is 150, then 1 multiplied by the bond energy value, which is 193. Okay, so this is 150, then this is 193. So the total energy needed is going to be 150 plus 193. So 150 plus 193 is 343 kilojoules. Okay, the next one is calculate the total amount of energy released when the bonds in 2 moles of IBr are formed. So bonds formed, okay, BF. This takes place on the product side. So on the product side, we have IBr bond and we have two of these. Okay, so I'm gonna write it over here, two bonds, and if I multiply this by the bond energy value, which is 175, so I'm going to get 2 times 175 equals 350 kilojoules. Okay, so that would be 350. Now, calculate the enthalpy change for the reaction. Your answer should include a sign. Delta H is equal to BB minus BF. So that is just a short way of saying total energy needed to break the bonds on the reactant side minus total energy released during bond formation on the product side. Okay, so we're going to say 343 minus 350, and that would be equal to minus 7 kilojoules per mole. Okay, so my answer is going to be minus 7. Okay, then the last part of this question is sodium is in group 1 of the group 1 of the periodic table. When sodium is added to water, a chemical reaction occurs. Give two observations when sodium is added to water. Again, you have to give the observation, something that you can see. So the first thing we can see is that solid dissolves or disappears. Okay, then we can also say that it floats or starts floating rapidly on the surface. Okay, we can also say that it forms a ball. It is better that if you don't understand this, you should go on YouTube and look, physically see that, okay, what happens when you add sodium in water. So you can actually, then you can clearly relate with these observations if you haven't done that already. Okay, it forms a ball, then you can also say that it melts and so on. Okay, you can also say that it burns with a yellow flame. Okay, so that is another observation as well. The last one is thymolphthalein is added to the solution when the reaction has finished. State the final color of the thymolphthalein in the solution. First of all, we need to know that what is the product being formed when sodium reacts with water. So when sodium reacts with water, we get sodium hydroxide plus hydrogen gas. Because sodium hydroxide is a base and the color of thymolphthalein in a base is blue, therefore my answer is going to be blue. Okay, this will be the final color of the solution. So that is the end of this exam paper. I hope that all the questions uh, were clear to you and you understood every single detail. Okay, make sure that you try this question by yourself as well. Okay, if you haven't done that already. So until then, I'll see you in the next video then. Take care. Assalamu alaikum.